This video is on Unit 5 on rational functions, Chapter 10, Introduction to Rational Functions, Lesson number 1, Simplify, Multiply, and Divide Rational Expressions. In your notes here, it says that a rational expression is a ratio of two polynomial expressions. So basically what that means is we are going to have fractions. We're going to have polynomials in fraction form. So to simplify a rational expression, first, we're going to factor everything that can be factored. Secondly, we're going to simplify the monomials, which means we have to use those exponent rules. And then thirdly, we want to eliminate common binomial factors. And I want to talk to you just a second about common binomial factors. So when we go to eliminate common binomial factors, those binomials have to match exactly. One would need to be in the numerator, one would need to be in the denominator. And I'll explain more about what that's going to look like here in just a second. The vocabulary word that I would like to add to your notes here is excluded values. Excluded values are any value of the variable that makes the denominator equal to 0. And the reason why we have to exclude them is because if the variable equals 0, or if the denominator is equal to 0, that creates an undefined fraction, an undefined term. So in every single one of these rational expressions, we always kind of have to keep our eye on the denominator and identify any variables that would make it equal to 0 and exclude those from our solutions. So in example number 1, we're just going to simplify this. 20x to the 6th divided by 14x to the 2nd. So these are both monomials. We've done this type of problem before. So if I'm going to simplify this, we're going to reduce the 20 and the 14, and that's going to become 10 sevenths. And then we're going to subtract our exponents. X to the 6th divided by x to the 2nd is going to be x in the numerator where we have the most x's, and 6 minus 2 is 4. So that's our answer on number 1. But going back to that denominator, the denominator says 14x squared. So essentially, if I set this equal to 0, x will not be allowed to equal 0. Because if x is equal to 0, then my denominator is equal to 0, and my whole entire expression is undefined. So little hint here, anytime you have a monomial in the denominator, the excluded value is always 0. Let's look at number 2. We've got 6k minus 36 divided by k minus 6. So we have binomials here, and we are going to factor out the GCF in the numerator. The GCF in the numerator is 6. 6k divided by 6 is k. Negative 36 divided by 6 is negative 6. And all of that is over that original denominator of k minus 6. Now, these are what we call common binomial factors. We have a k minus 6 in the top and a k minus 6 in the bottom. So those will cancel, and my final answer here is just 6. And again, to focus on those excluded values, go back to the original denominator, set it equal to 0, add the 6, and that's what k is not allowed to be. So 6 is an excluded value. All right, let's keep going. Let's jump down to number 3, y plus 8 divided by y squared plus 2y minus 48. So the numerator is a binomial. I can't factor it any further. There's no GCF. The denominator is y squared plus 2y minus 48. So I'm looking for two numbers that multiply to give me negative 48, that add to give me 2, which is going to be a negative 6 and a positive 8. So I've got a y plus 8 in the top, and a y minus 6, and a y plus 8 in the bottom. Your common binomial factors here are the y plus 8s. They will cancel. So I get 1 over y minus 6 for my solution. Now, when we talk about excluded values, what we want to do is go back to that original denominator, but in factored form. So I can't just look at my answer, which is 1 over y minus 6, to find my excluded values, because I have to look at maybe anything that might have been canceled. So if you look at the original denominator in factored form, y cannot be a 6, and y cannot equal a negative 8. So your two excluded values for number 3 are a 6 and a negative 8. I want to look now at number 5. P squared minus 49 divided by 7 minus p. The numerator is the difference of squares, and it's going to factor into p minus 7 times p plus 7. And if you notice my denominator, 7 minus p, is not quite like the p minus 7. And there's a little box here that says watch out for a minus b over b minus a. Those are not common binomial factors. So basically what I'm going to do here is I'm going to try to manipulate the denominator so that I do have a p minus 7. So if I factor out a negative 1 from that denominator, I get a negative 7 plus p. Negative 7 plus p is the same thing as p minus 7. So I've changed the way that denominator looks, and now I have common binomial factors of p minus 7s that I can cancel. And I will have p plus 7 over negative 1. And I don't like negatives in the denominator. The trick here, though, is that you can't just move that negative to the numerator, because it would be negative times the p plus 7. So your final answer here is negative p minus 7, because that's going to distribute through to that binomial. If I were asking you about excluded values, again, you're going to go back to that original denominator. In factored form is not really going to change this because it doesn't really factor. So if I take that 7 minus p, set it equal to 0, I'm going to add the p. The excluded value here would be 7. P could not equal 7. Let's jump to number 9. So in this section, we are multiplying rational expressions. If the problem contains monomials only, you want to multiply together, then simplify. If it contains binomials and trinomials, what you need to do is factor everything you can first, then simplify. So I'm going to look at example number 9 exactly the way that says. So I'm going to multiply together and then simplify. So the way that we multiply fractions is if you've got two fractions, you just multiply across the top, multiply across the bottom. So the top for this one, 6 times 10 is 60. X to the add your exponents, y to the add your exponents, over 2 times 18 is going to be 36. X to the second, y to the fourth, because again, you're adding those exponents. Now what we want to do is we want to reduce that fraction just like we did back on example number 1. If you simplify your 60 over 36, you're going to get 5/3. And then for your x's, 5 minus 2 is 3. And your y's, 7 minus 4 is 3. So that's how you get the answer there. I'm not going to worry about excluded values at this point. We are going to, at this point, assume that all denominators are defined. I want to show you a different way of doing that. So if you look at example number 10, instead of multiplying everything and then reducing, I like to try to reduce first. So when you are multiplying fractions, you are allowed to cancel or divide out common factors. You can divide out common factors crossways or within the same fraction. So if I look at this first fraction, my a squared and my a in the denominator are going to cancel, leaving me with an a in the top. And the 2 b's in the numerator will cancel with 2 of the 3 in the bottom, leaving with b in the bottom. So now I have 4a over 15b times, in my other fraction, 5 and 12 are not going to reduce. My a's are going to end up in the bottom. 4 minus 3 is 1. My b's are going to end up in the bottom. 7 minus 6 is 1. I'm still not done. I can cancel now. So that took care of within the same fractions. Now let's go crossways. Is there anything that 4a and 12ab have in common? They both have a 4a. So 4a divided by 4a is 1. 12a divided by 4a is just 3. And then the other crossways, 5 and 15 are going to reduce by 5. 5 goes into 5 once, 5 goes into 15 3 times. Now I'm going to multiply across. So 1 times 5 is 5. And then in the denominator, 3b times 3b is 9b squared. So there's two different ways that we can go about doing that. Actually, you know what? I did that wrong. I multiplied wrong. I divided wrong, actually. 5 divided by 5 is a 1. This should have been a 1. I'm so sorry. So that's a 1, not a 5. I'll probably screaming at me. 5 divided by 5 is 1. 15 divided by 5 is 3. So in the numerator, we just have a 1. So there's our answer. So you can use whatever method you want to on monomials. Let's talk about when we've got binomials and trinomials. So let's look at number 11. In the numerator, 4x squared minus 4x has a GCF of 4x. Divide that out, we get x minus 1 over 2x squared plus 4x minus 6 has a GCF of 2. I'm going to just kind of reduce this a little bit here before I move down. So I pull out the 2, divided out the 2. Now I got a trinomial that's going to factor. Two numbers that multiply to give you negative 3 that add to give you a positive 2 would be a positive 3 and a negative 1 times. In the numerator, on the second fraction, two numbers that multiply to give you negative 6 that add to give you 1 is going to be positive 3 and a negative 2. And in that denominator, 4x squared plus 8x, there's a GCF of 4x, leaving us with x plus 2. So again, in this situation, you want to look within the same fractions to see if there's anything that can simplify. So the x minus 1s will cancel. And 2 is going to go into 4. 2 goes into 4 2 times. Nothing else is going to cancel in that fraction. In the second fraction, nothing's going to cancel. So now let's look crossways. So I have a 2x still left in the top left that will reduce with the 4x in the bottom right. So they both have a 2 and an x in common. So this is going to go away. And 4x divided by 2x is 2. And now we want to go the other direction. The x plus 3s are going to cancel. Those are gone. And then all we have left at this point is an x minus 2 in the top and a 2 and an x plus 2 in the denominator. And that is your answer for number 11. Please leave it just like that. You do not need to distribute. The last thing that we want to look at is division. When we divide fractions, the rule says to divide rational expressions or divide fractions, we multiply by the reciprocal. You might recall teachers saying, keep it, change it, flip it. What that means is you want to keep the first fraction as it is, change the division to multiplication, and then flip the second fraction. So on number 13, we would keep the 5p cubed over 16p cubed. We're going to change divide to multiply, and we're going to flip that other fraction. And then we can use whatever method you want to. These are all monomials, so you can go ahead and multiply the tops, multiply the bottoms, and simplify, or you can reduce your fractions, which is what I'm going to do. 8 and 16 are going to reduce. 5 and 35 are going to reduce. There's lots of P's and Q's that are going to go away here. So let's look in the first fraction. So there's a P in the top that will reduce with one of those in the bottom, leaving me with a P squared. There is a Q here in the first one that will reduce with two of these here, leaving me with one in the bottom. What else? The Q in that bottom right will then cancel with one of these in the top, leaving me with Q to the fourth. I think I have everything simplified, but we'll find out when we multiply across. So multiplying across the top, all I see is a Q to the fourth, and all I see in the bottom is a 14 P to the fourth. Don't lose that. So there's your answer on number 13. Monomials are probably my least favorite to divide. I'm going to show you an example of one more. Let's look at number 15. We've got division here. We're going to keep the first fraction, change to multiplication, flip the second fraction. I'm going to try, well, let me just write this out. So you got 2a cubed minus 12a squared over the a squared minus 4a minus 12 times flip, and then we're going to factor. So top left GCF is a 2a squared, leaves me with a minus 6. In the bottom, two numbers that multiply to give me a negative 12, that add to give me a negative 4 would be negative 6 and a positive 2. Top right, two numbers that multiply to give me 15, that add to give me negative 8 would be negative 5 times negative 3. I was thinking 3 and wrote a 5. So this is going to be a 3. And in the bottom, there's a GCF of 8a squared. And that's going to leave me with 3 minus a. Okay. So I already see an issue with my signs on this one. Let's go ahead and cancel inside each fraction. Let's go this way. So your a minus 6's are going to cancel. And in the second fraction, your a minus 3 will not cancel with 3 minus a. So I'm going to make that a negative 8 so that the 3 becomes negative and the a becomes positive, so that now those two binomials cancel. From here, if we look this direction, nothing will cancel. But we look this direction, the 2a squared is going to reduce with the 8a squared. The a squares are going to completely go away. 2 goes into a negative 8, negative 4 times. Okay, so let's multiply across the top. Across the top, we have an a minus 5 over the negative 4 times the a plus 2. And again, I don't like that negative in the bottom. So we're going to move it up to the top. Which is going to, you can leave it negative, parentheses, a minus 5, or go ahead and distribute that one. And there's your answer for number 15. On number 16, I would set this up, flip, change and flip, and then just leave this last one because it is multiplication. So you would just be doing all of this at the same time. And we can do that with fractions like this. So the 16k squared minus 1 is the only thing that's going to factor. and it would factor into 4k minus 1 and 4k plus 1. So I'm going to cross that out. So I've got it in factored form. And then at that point, you just have to make sure that if you're looking for your common binomial factors, one has to be in the top, one has to be in any bottom. So the k plus 3's can go away. The 4k plus 1 can cancel with the other 4k plus 1. And all we have left is a 4k minus 1 in the top and a k in the denominator. So that's how that's done when you have more than one fraction. But there are your notes for Chapter 10, Lesson number 1.